from David. Ooh, no, it's not live. You got it. Okay. So here we go. This is talk number 6 on the DevSecOps track. I hope you viewers are having fun. I'm learning a lot already. 6 down, which puts us about a quarter of the way through. So there's a load more DevSecOps things coming. And of course, there are other tracks for those for other talks as well. Now we have David to talk about, I love this, threat modeling, the ultimate push left, which I think is just great. David, I will get out of your way and hand it over to you. And, I'll come back just near the time that it's time to wrap up. So thank you very much for being here. And the floor's all yours.
Thank you, Steve. Really appreciate that. So start with a quick introduction about myself. I'm a chief architect at NI. We're actually just purchased by Emerson, so I guess this is a week out of date. My division handles big data analytics for manufacturing, which is a super interesting space. And my job is to design enterprise-grade solutions for gathering the data, processing the data, and analyzing it, which is a lot of fun. But on the side, I'm also the lead of the product security chapter, which brought me into the security world. And I handle their ISO audits and things in that realm, and setting up the DevSecOps program. Passions, I love application security. Didn't know I would say that 5-6 years ago, but it really is interesting. It's a fascinating field. I've always been a huge fan of clean, testable, readable code. And not like most people, I love modernizing aging systems. Everybody knows your system has to last more than a couple of years. And the answer is not to rewrite it every 3 years. So I really like finding the beauty in the older systems and then bringing them into the modern. But let's get down to our main topic. Threat modeling and DevSecOps. To do that, we really need to take a step back and understand DevSecOps and where it came from. So I'm going to give a quick overview. And to give an overview on DevSecOps, you really have to start at the beginning, which is Agile. Agile really solved a very large real-world problem. Back in the day, the customer would tell you, we want you to build, something, and this famous cartoon is, I think most of you have probably seen it before, but it's very accurate. Even the customer doesn't tell you what they actually need. They don't know. And the project leader certainly doesn't. They try to translate it for the analyst who translated it for the programmer. By the time the programmer got his hands on it, he had lost all context. And the problem really was that they were trying to build too big a system and not getting any feedback from the customer. You needed to bring back the collaboration with the customer and allow for rapid deployments of real-world software that works and getting feedback so that you can make it better and better and build upon it in much smaller increments. And this worked really well. Everyone loved it. It was the first time that a customer, in a normal period of time, got to see something real before it was finished and then give their involvement in it and really improve it. So when at the end of the day, they got what they really wanted. And then there were new problems because sure, the QA and the product representing customer and developers were working together beautifully in Agile, and it was a beautiful cycle. When they were done, they would make up this package, throw it over the big red brick wall to the operations team who had to then deploy that piece of software. And inevitably, something was wrong. Either the instructions to the operations team weren't right, or they coded it in a way that didn't quite make it ready to be put into production. And the operations team had to send back bugs to the development team, and it went back and forth and back and forth and back and forth. And this was always after the delivery timeline, meaning the development team had finished their work. They were on to new things, and all of a sudden bugs are coming back. It doesn't work because it doesn't handle a load balancer, or it doesn't work because it doesn't support HTTPS or and. And so DevOps was born, and the idea behind DevOps was a whole bunch of things. I'm giving 3 highlights for me. The first is collaboration, the same thing that made Agile so great. You have the collaboration between the customer, the product, the developers, and the QA, and they all work together at the same time to produce something. Bring the ops in there. So when you sit down at the planning, the ops already say, well, how are we going to deploy this? What is it going to look like? And that gets into the planning, and the cycles are smaller. The ops get the code more often. Well, they also introduced a beautiful thing called automation. Instead of ops figuring out how to manually deploy the software, DevOps said we have to move faster and we have to be able to do this better, and the developers have to have a little bit more hands. So we created things like Helm charts where the developer can write that. The ops team builds the infrastructure to get that to actually go, but they do it with the developers, and the developers can actually build a large portion of the deployment. And it's standardized and repeatable, and that's beautiful. And then shift left was born. Shift left, I mean, truly Agile is also shift left, but shift left became a term in the DevOps culture whereby if something wasn't going to work in production, you would find out about it the first week into the cycle, because you would already have run the CD. You would already have seen that it failed the deployment or various other things in that way. QA testing became much more automated, allowing us to be sure that the code we were shipping was quality and that it worked and we didn't break anything, because you can't deliver fast if you keep breaking things. And finally, infrastructure as a code was really the ability to have lots of people be involved with building the deployment code as opposed to only the ops people being able to do it. So DevOps was great, and we were super happy, and things were moving along fast. And then we hit the security team. Security was always left behind. And as the numbers of cyber attacks went up over the years, big companies said, well, we have to do something about this. So they put a security team in between the DevOps process and production. You could deploy to your CI environment, you could deploy to your testing environment, but you're not going live to production until the security team reviews every single last setting. And that made it slow again. Worse than slow, there were things that should have been done in the coding time that got caught only at the end. And we needed a way to, to remediate those, but to remediate them fast, because we were supposed to have delivered already again. It was like bringing back the ops team separation again, but just with a different team, the security team. And it also, everyone walked around going, the security team always says no, and that was always a problem. And so DevSecOps said, okay, someone came up with the idea and said, hey, let's use DevOps values to solve the problem. Some of the things are not on here, like leaning in, where you talk to the security team and help them understand that they have to find solutions, not just say no, that's fine. But the main things are collaboration. You have your DevOps and your security working together throughout the cycle, always checking everything. And automation, just like in DevOps, we introduced code quality automation and regression testing automation and all kinds of CI/CD things. We suddenly were able to put security scans into that CI/CD pipeline to allow things to just move along quickly and still catch all of the issues really early. And shift left, the idea again from DevOps that you want to have a fast feedback. I don't want to wait 3, 4, 5 months to find out that I use the Kubernetes secret store instead of something else and I didn't encrypt it, or that there was a SQL injection attack vector in my code. I don't want to find that out 3, 4 months in. I want to find it out the day after I check in that code. I want the CI/CD to run. I want it to give me back a report. You have SQL injection, or you have a misconfiguration of your Kubernetes cluster, and I should know right away that I need to fix it. It allows us for faster delivery, and it allows for seamless motion between the things. Now, let's talk a little bit about threat modeling. If I had to summarize threat modeling in 2 words, I would say identifying vulnerabilities. Threat modeling is about finding vulnerabilities before the hackers do. They will find them. The hackers will find anything you put in there, and being able to mimic their methodologies or in any other way, finding the vulnerabilities early is really the goal of a good threat modeling process. It's not new either. Threat modeling was not invented with DevSecOps. Threat modeling has been going on since the first computer systems were rolled out and the first hackers tried to break into them. Some of the older methods are a lot heavier, like asset-centric, which basically means that you take a list of every single thing you're trying to protect, not every piece of your system, everything you're trying to protect, my data, the money in the bank, or various other things like that. And you make a list of how someone might go about attacking those assets and getting control of them in ways that you don't want. Listing all the assets is a little hard, so people came up with a different idea. Let's consider who our attackers are. And we'll make an attacker-centric threat modeling. We point out all the attackers that are out there and how they might try to attack us. And using that, we find vulnerabilities that we might be able to locate. Also hard to do though, because we don't know who the attackers are. And even if we map it out today, tomorrow it could be different. Software centric was kind of taking the sweet spot between the two. We're looking at our piece of software, mapping out every piece of it and looking for vulnerabilities within each of those components and pieces. And that also works well. Also heavy though, I'm looking at an entire system at the end after it's live and trying to figure out where things can go wrong, or even at the beginning and trying to see where things go wrong. So when DevSecOps came up, people came up with a slightly lighter framework for threat modeling, which we're going to talk about today, which is the 4-question framework. I put the sources on the bottom from OWASP and Adam Shostak, not because they're the only ones who talk about it, but because if you link there, you can get to all kinds of other links about it and also some great videos. So definitely worth checking out. The 4-question framework basically works like this. You get a whiteboard and you sit down and you do, what are we working on? That's what a lot of people call scope. You don't want to look at the whole system. You'll never move forward. You'll be there all day. It'll take hours and hours every time you want to do threat modeling. When you draw out every single component and look for every single vulnerability each time, you want to know, what am I changing today, very specifically in the system that I have worked with, and then I can take from there. I can figure out what I have to look at. Given what I'm working on, scoping, I then go to what can go wrong. And this is really looking for those vulnerabilities. And you sit down and you go, in whatever fashion you tend to do it. I personally will discuss later. I personally like working collaboratively with people live, but there are all kinds of ways of doing it. And you try to answer what things could be exploited in this system and what could happen if they are exploited, and how could we end up with problems? What problems could we end up with? And then part 3, you take the list of those problems that you just listed and you say, okay, what can I do about that? Sure, there are always vulnerabilities, but what can I do about it? Which things can be fixed? How can I mitigate? If I can't mitigate, what can I do to, somewhat protect myself from some of these vulnerabilities? And finally, at the end, as in any good process, you always want to reflect back and say, were the mitigations I picked for the vulnerabilities that I found the ones that I'm happy with? Am I good with, with the results of this threat modeling, or do I need to do it again? And how was the process also, so that you can always improve the process for the next time? 4-question framework gives you a lot of, useful information and a lot of useful interactions without a lot of heavy, listing everything's or trying to go through the whole system. So it's kind of a great option for something that's going to be done iteratively on an ongoing basis. This is not threat modeling specific, it's not the 4-question framework specific, but it is very helpful when you first start off in threat modeling. There are a bunch of models. I like the STRIDE model. It's one of the easiest. It gives you 6 things that you should be looking for. Again, you can Google it and you'll find more, or you can click the link on this slide and it'll take you to a web page which has, the definitions of each of these. But quickly, I'll give you an overview. Spoofing is when you pretend to be someone you're not. This is the classic example of this is if someone steals your username and password and then goes into your system and does something. They are spoofing you. It's usually a failure of authentication. That is, and the solution to it is usually tighter authentication in some form. Tampering is when someone plays with data that they shouldn't be playing with, or changes something that they shouldn't be able to change. This would be if an anonymous user who has no rights on Wikipedia were to update the Wikipedia page with all kinds of awful things. That would be tampering. Or if someone can change your database records or your configuration, that would be tampering. Repudiation is one that trips up most people. Repudiation is not the control here is to not allow repudiation. Repudiation means saying that I didn't do something. I go to the bank and I say $100 was taken out of the ATM. It wasn't me. And they say, well, of course it was you. And I say, no, it wasn't me. They can prove that it was me. That would be repudiation. They'll be able to repudiate. I won't be able to repudiate that I did it. They'll be able to prove that I did. It's a way of tracking who did what and making sure that only the right people are doing what they need to be doing. Information disclosure is the #1 risk currently on the internet. As far as I'm concerned, that is someone is going to get into your system and steal data. Data is everything these days. So this is a major one. Anything that will allow your data to leak out of your system should definitely be locked down and considered. Denial of service is the classic internet attack. They come and they bombard your system with 100,000 requests at the same time, the server goes down. That's a denial of service. You can have them from lots of different ways, but that's just one example. Finally, elevation of privilege is the stepchild, which no one ever looks at, but it's probably the best attack. I have access right now to the All Day DevOps platform because I'm speaking here today. If I could go in and cancel all the sessions, that would be an elevation of privilege. I shouldn't have those rights. But if I can find a way to break through the controls on the platform and do something that even though I'm allowed on the platform, I'm not allowed to do that, that's elevation of privilege. And it's an interesting risk and really, really important to lock down. So now let's take a look at threat modeling and DevSecOps. Where does it fit into the DevSecOps model? I mean, as much as anyone else, I'll tell you most of DevSecOps is about automation. And that's great. I love the automated security scans. I love the tools we put in to make sure people can't put in dangerous code. Where's threat modeling? Well, threat modeling is really about how early is the threat identified. You know, when we talk about pushing left, the last place you want to be is finding a threat in production. When you find a threat in production, first of all, the cost for repair is so high. Second of all, production is down or production is compromised. And you have to decide whether you want to pull production down until that compromise is gone. That's a terrible place to be. Not quite as bad, but almost as costly as when the security team reviews it at the very end, right before it goes into production. That's also an awful place to be because it's expensive. It's a little less expensive than production because you don't have to deal with a live system that's running, but it means that you have to go back to the developers, have things repaired, tested, packaged, and then deployed in order to fix it. You could do a pen test before. That's the same as a security team review as far as I'm concerned. Automated security scans are wonderful. I really love them. It means that you have something checking before it's going out there. And the truth of the matter is you can catch a lot of things in the nightly CI. So it's not even such a long time to wait. And some scans can even happen on every PR. People run SAST scanning tools on every single PR. And there are ways to enforce, software composition analysis on a PR by PR basis. Some of the tools now have the ability to, on the PR, evaluate what packages are new and are they vulnerable. And that's really great because that's super fast feedback. A developer finishes a little bit of work, runs a PR, and finds out immediately what they need to fix, and then goes back and does that. So that's relatively cheap. But we know what's even cheaper? What's even cheaper is threat modeling before you start. If you can sit down in a short session, and we'll discuss how short later, and actually identify what the major issues are and how you want to remediate them, the automated security scans, they'll still find whatever you miss, but you won't have to use them as much for that protection. The major benefit here is, or one of the major benefits, is that the security team gets a seat at the planning. When you sit down to plan a new user story or new feature, and you want to do your threat modeling at the beginning, you don't do it alone. The security team comes in, and you have security, and you have QA and DevOps, and your ops person and your developers, and they're all sitting around, and together they're looking at security, and that gives us multiple benefits. Back to our threat modeling, to our DevSecOps model, it doesn't give you a lot of automation, but it gives you a tremendous amount of collaboration. 15 years ago, when I was in software development, I never met the security team. I got back bugs from them, but I didn't know who they were. If I had a question, I didn't have anyone to ask. You now know the security team, and they can teach you a lot, and you can teach them a bunch too about what the software does. And together, you can really learn about security and the software. And shifting left, well, this is the most left it can go. You're all the way back to the beginning of the system before anything's happened. No code's been written. Nothing has to get redone. You're saving tons of work, and you're making sure that security is called out at the very beginning. Well, that's why I call it the ultimate push left, because it really is to the very beginning of the cycle. And it's really something that delivers a lot of value and saves a ton of time. But for it to be worth doing for every single feature, it's got to be quick. So I'm going to walk you through now threat modeling in 30 minutes or less. Quick how-to guide. Let's start with step one. This is the most important step. If you can do this, you're probably going to get something out of this. Get the right people in a room with a whiteboard. Okay? The right people are the security expert, developers, QA, product manager, and ops. Everyone has something to give here. Because the security expert can tell you what the issues might be if you don't figure them out yourself. But hopefully over time, you'll need his input to do that less. But he can help you understand how severe the issues that you come up with are. The developers understand the code well enough to be able to find things that even the security team wouldn't think of. QA always has its own mindset. I love having QA in meetings because they just think about the world differently, and that's really special and really helps a lot to understand things. The product manager has to be there because the question of what is acceptable risk is not really, it's also a security question sometimes, but sometimes it's really like, this is the risk you're taking, or these are the issues for performance it's going to cause, and is that good enough? And the ops engineer obviously is the one that has to implement this, so they're going to understand some of the nuts and bolts better. Those are the people to have in that room. And a whiteboard, I say, because to me, it has to be brainstorming. This is not an exhaustive exercise. You probably won't find all the issues. Your automated scanning will still find things, guaranteed. I don't think you're ever going to be 100% free of that, of your interactive, dynamic pen testing tools, or your SAS tools, or your SCA coming up with something that didn't exist when you were sitting in your threat modeling session. And then it came out, 0 day came out 2 days later. There's always going to be new stuff to find, but it will help you start thinking about security. And it will help you also to get the developers to understand security much better. And that's such a valuable thing, to have developers and QA and the ops to understand security and not just be told something by the security team, say, okay, they said no, so what am I supposed to do? To really understand how to do risk analysis and really how to understand how to mitigate issues. That's very valuable. Step 2, not everyone knows how to threat model. So it's worth sitting down and explaining how it works. Start by explaining the 4-question framework. Not complicated. What are we working on? What could go wrong? What are we going to do about it? And did we do a good job? People have no problem understanding that. Usually it's pretty quick. Stride sometimes takes a bit longer, but it's worth doing because it helps educate the people in the room so that everybody can come up with issues, not just that security expert. Straight off the bat, people can say, oh, well, what happens if? Could someone get in if they, could they break authentication and do spoofing? Let me think about that. And it gives them a direction to start thinking about. And finally, set expectations. We're not, what are the limits to what we're doing? We're only talking about this. Or what are we planning on getting out of this session? And what are we going to do with the information afterwards? It's definitely good to set out the framework. Step 3, you're ready to go. Just do the threat modeling. See how it goes. Doesn't go well in question 4, how did it go? You'll figure it out and you'll say, next time, let's do this a little different. You'll find your way, but don't be afraid to just do it, because the benefit is more than, the loss of doing it wrong. If you do it wrong, so nothing happened. You're not any worse off than you were before, but you probably will learn things each time to really make up a better system. And finally, number 4 is a really important one. It's not part of the 4-question framework, but it's really important. The end of a threat modeling session can't be that we all leave the room and say, okay, that was nice. We learned new things. We have stuff on the board. It has to have results in something. That could be user stories or tasks in your in your project tracker. It could be bugs, if they're existing things, or if you feel that they're bugs for some reason. And it also should probably go in your design document. Say, this is the threat modeling we did. Here are the mitigations we said we were going to include. And that is how we think we should be handling this going forward. Documenting is super important because people forget. You do a threat modeling in September, you deliver the feature in November, no one's going to remember to check them. But if you made a bug out of it, then you're going to remember to fix that bug because you need to clear it. If you made a user story out of it, you're going to have an acceptance. And if it's in your design document, your architect's going to have to sign off on it, or whatever your process is around design documents. So it's important to record the results to make sure that you get the maximum benefit out of the threat modeling session. And that's it for threat modeling. Just stressing again, I think that it's short, 30-minute sessions with people in a room, raise collaboration, really educate yourself about security, even if you're not a security professional, and you'd be surprised how fast you can learn. Produce out, some really nice detailed tasks that you can do afterwards. And even if all you walk out with is one bug and a feature, that's great. Or if you walk out with nothing, except for a lot of knowledge, it's also wonderful. because at the end of the day, developers who are focused on security are going to produce more secure code than developers who aren't. And educated developers are going to produce more secure code than those who are not. And having the security officer there at the beginning really helps them understand what's at stake and why things need to move forward faster. So that collaboration and the discussion and the working together really produces amazing results. So give it a shot. And if you have any questions, I'll be in Slack after the session and be happy to answer.
Wow, David, thank you. I'm sitting there nodding right from the beginning, all the way through this. Yes, I remember when we started DevOps and the Agile Connection, and all the way through this, and this is really cool. And the pun here obviously is that developers should and DevOps guys should take all this stuff, in their stride. That was really good. Thank you so much for being on AGDO, All Day DevOps. There we go, folks. That's number 6. There's a load more to go. Please stay with us, and the next awesome talk will be along in about 4 minutes. So I think we'll shut this one here and give everybody a few minutes to go grab some coffee and breakfast and dinner, whatever it is, wherever you are in the world, because obviously we have 24-hour lessons, so we have the world looking at us, and come back in a few minutes and see the next one. Anyway, thank you very much, and thank you again, David.
Thank you.